Hi everyone. Thank you for coming to watch our presentation. My name is Daichi Ishikawa at Osaka University. I'm going to talk about a mixed reality coordinate system for multiple head-mount display users manipulating real-time point cloud objects for sharing 3D physical objects in Teleconference. Here's the outline. Introduction. Our research background is consisted of three elements. Firstly, hybrid meeting that participants can join from anywhere. Teleworking enables us to work from home, that is, we don't need to pay for travel costs. Furthermore, we can collaborate with other people in a remote area when pandemic or natural disasters has been occurred like the current situation. Secondly, 3D visualization using virtual reality. 3D visualization helps us understand 3D information such as spatial composition or shape of 3D objects. Thirdly, real-time point cloud objects, which are 3D models created automatically using an RGBD camera. Point cloud objects are good at representing the shape of 3D physical objects in real time. From literature review, we confirmed a disadvantage of VR that we cannot feel realistic experience. And we can solve the problem by using mixed reality, which integrates a virtual environment with a physical environment. In our previous research, we proposed a 3D remote sharing system using point cloud objects and MR head-mount display. But the system has a limitation of the number of MR head-mount display users. Only one person can see the point cloud objects. So in this research, we aim to present a remote sharing method of the MR coordinate system among multiple MR head-mount display users to share point cloud objects interactively and synchronously. Proposed method. This is the overview of our proposed system. At first, point cloud data of a sender and physical objects is captured by an RGBD camera and segmented in a server PC in Site A. And next, point cloud data is transferred to Site B by a local area network with a world anchor, which is a reference point of the real world and the most important part of our research. Then, receivers can see point cloud objects through the MR head-mount display at the same position if one user manipulates them thanks to the world anchor. In this system, point cloud data is segmented as a below figure. So we decide the parameters for point cloud processing through parameter study. As a result, we confirm the parameter for downsampling affected the average FPS. So we decided to set 1500 mm and 1000 mm and 10 mm as the parameters of clipping, filtering, and downsampling. We applied the world anchor to share the MR coordinate system among multiple users. The world anchor is a reference point of the real world. When our proposed system starts, a world anchor is put out according to the start position. And then the world anchor is transferred to another MR head-mount display by a server PC, and this MR head-mount display has the same MR coordinate system. We measured the error of the position of point cloud objects between two HoloLens, but the error was within the tolerance of our proposed system. Experiment and results. We evaluated the usability of the prototype system by multi-users. Below figure shows the position of participants. This video shows the two receivers' view through HoloLens. Now the sender is appeared as a point cloud object. He was moving, so the point cloud object was also moving. And now the physical object is appeared. As you can see, receiver A and B could see the point cloud object at the same position in real time. And this video shows the result of manipulating point cloud objects by receivers. Now receiver B is moving a point cloud object. As you can see, the result of the manipulation by a receiver could reflect another receiver's view in real time. This slide shows the results from the experiment. We accomplished the virtual and interactive 3D synchronous sharing of point cloud objects between two HoloLens users, sharing the MR coordinate system by using word anchor. And it would contribute to the first step towards virtual and interactive 3D synchronous sharing of physical objects in teleconference during design study. We got pros and cons as below from the open-ended interview. Conclusions and future works. We presented a method to share the MR coordinate system for multiple head-mount display users manipulating point cloud objects for the virtual and interactive 3D synchronous sharing in teleconferences, and sharing word anchor between two MR head-mount displays for corresponding to their MR coordinate system synchronously to reflect the manipulate of point cloud objects. Future works. We have to use multiple RGB cameras to create point cloud objects that have all surfaces. And we also have to apply the internet environment, not only LAN, to extend the range of use. Thank you for your attention.